A thought experiment or Gedankenexperiment considers some hypothesis, theory, or principle for the purpose of thinking through its consequences. Given the structure of the experiment, it may or may not be possible to actually perform it, and if it can be performed, there need be no intention of any kind to actually perform the experiment in question. The common goal of a thought experiment is to explore the potential consequences of the principle in question. A thought experiment is a device with which one performs an intentional, structured process of intellectual deliberation in order to speculate, within a specifiable problem domain, about potential consequence for a designated antecedent. Famous examples of thought experiments include Schrödinger's cat, illustrating quantum indeterminacy through the manipulation of a perfectly sealed environment and a tiny bit of radioactive substance, and Maxwell's demon, which attempts to demonstrate the ability of a hypothetical finite being to violate the second law of thermodynamics. Overview. The ancient Greek delta epsilon iota kappa nu upsilon mu iota, or thought experiment, was the most ancient pattern of mathematical proof, and existed before Euclidean mathematics, where the emphasis was on the conceptual, rather than on the experimental part of a thought experiment. Perhaps the key experiment in the history of modern science is Galileo's demonstration that falling objects must fall at the same rate regardless of their masses. This is widely thought to have been a straightforward physical demonstration, involving climbing up the Leaning Tower of Pisa and dropping two heavy weights off it, whereas in fact, it was a logical demonstration, using the thought experiment technique. The experiment is described by Galileo in Discorsi dimostrazioni matematiche thus: Salviati. If then we take two bodies whose natural speeds are different, it is clear that on uniting the two, the more rapid one will be partly retarded by the slower, and the slower will be somewhat hastened by the swifter. Do you not agree with me in this opinion? Simplicio. You are unquestionably right, Salviati. But if this is true, and if a large stone moves with a speed of, say, 8 while a smaller moves with a speed of 4, then when they are united, the system will move with a speed less than 8, but the two stones when tied together make a stone larger than that which before moved with a speed of 8. Hence the heavier body moves with less speed than the lighter, an effect which is contrary to your supposition. Thus you see how, from your assumption that the heavier body moves more rapidly than the lighter one, I infer that the heavier body moves more slowly. Although the extract does not convey the elegance and power of the demonstration terribly well, it is clear that it is a thought experiment, rather than a practical one. Strange then, as Cohen says, that philosophers and scientists alike refuse to acknowledge either Galileo in particular, or the thought experiment technique in general for its pivotal role in both science and philosophy. Instead, many philosophers prefer to consider thought experiments to be merely the use of a hypothetical scenario to help understand the way things actually are. Variety. Thought experiments have been used in a variety of fields, including philosophy, law, physics, and mathematics. In philosophy, they have been used at least since classical antiquity, some predating Socrates. In law, they were well known to Roman lawyers quoted in the Digest. In physics and other sciences, notable thought experiments date from the 19th and especially the 20th century. But examples can be found at least as early as Galileo. Origins and use of the literal term. Johann Witt Hansen established that Hans Christian Ørsted was the first to use the Latin-German mixed term Gedankenexperiment circa 1812. Ørsted was also the first to use its entirely German equivalent, Gedankenversuch, in 1820. Much later, Ernst Mach used the term Gedankenexperiment in a different way, to denote exclusively the imaginary conduct of a real experiment that would be subsequently performed as a real physical experiment by his students. Physical and mental experimentation could then be contrasted. Mack asked his students to provide him with explanations whenever the results from their subsequent, real, physical experiment differed from those of their prior, imaginary experiment. The English term thought experiment was coined from Mack's Gedankenexperiment, and it first appeared in the 1897 English translation of one of Mack's papers. Prior to its emergence, the activity of posing hypothetical questions that employed subjunctive reasoning had existed for a very long time. However, people had no way of categorizing it or speaking about it. This helps to explain the extremely wide and diverse range of the application of the term thought experiment once it had been introduced into English. Uses thought experiments, which are well-structured, well-defined hypothetical questions that employ subjunctive reasoning. What might happen if, have been used to pose questions in philosophy at least since Greek antiquity, some predating Socrates. In physics and other sciences, many famous thought experiments date from the 19th and especially the 20th century. But examples can be found at least as early as Galileo. In thought experiments we gain new information by rearranging or reorganizing already known empirical data in a new way and drawing new inferences from them, or by looking at these data from a different and unusual perspective. In Galileo's thought experiment, for example, the rearrangement of empirical experience consists in the original idea of combining bodies of different weight. Thought experiments have been used in philosophy, physics, and other fields. In law, the synonym hypothetical is frequently used for such experiments. Regardless of their intended goal, all thought experiments display a patterned way of thinking that is designed to allow us to explain, predict and control events in a better and more productive way. Theoretical consequences. In terms of their theoretical consequences, thought experiments generally challenge a prevailing theory, often involving the device known as reductio ad absurdum, confirm a prevailing theory, establish a new theory, or simultaneously refute a prevailing theory and establish a new theory through a process of mutual exclusion. Practical applications. Thought experiments can produce some very important and different outlooks on previously unknown or unaccepted theories. However, they may make those theories themselves irrelevant, and could possibly create new problems that are just as difficult, or possibly more difficult to resolve. In terms of their practical application, thought experiments are generally created in order to challenge the prevailing status quo, identify flaws in the argument presented, to preserve objectively established fact, and to refute specific assertions that some particular thing is permissible, forbidden, known, believed, possible, or necessary. Extrapolate beyond the boundaries of already established fact. Predict and forecast the indefinite and unknowable future. Explain the past. The retrodiction, postdiction and hind casting of the indefinite and unknowable past. Facilitate decision-making, choice and strategy selection. Solve problems, and generate ideas. Move current problems into another, more helpful and more productive problem space. Attribute causation, preventability, blame and responsibility for specific outcomes. Assess culpability and compensatory damages in social and legal contexts. Ensure the repeat of past success, or examine the extent to which past events might have occurred differently. Ensure the avoidance of past failures. In science, scientists tend to use thought experiments in the form of imaginary, proxy experiments which they conduct prior to a real, physical experiment. In these cases, the result of the proxy experiment will often be so clear that there will be no need to conduct a physical experiment at all. Scientists also use thought experiments when particular physical experiments are impossible to conduct, such as Einstein's thought experiment of chasing a light beam, leading to special relativity. This is a unique use of a scientific thought experiment, in that it was never carried out, but led to a successful theory, proven by other empirical means. Relation to real experiments. The relation to real experiments can be quite complex, as can be seen again from an example going back to Albert Einstein. In 1935, with two co-workers, he published a famous paper on a newly created subject called later the EPR effect. In this paper, starting from certain philosophical assumptions, on the basis of a rigorous analysis of a certain, complicated, but in the meantime assertedly realizable model, he came to the conclusion that quantum mechanics should be described as incomplete. Niels Bohr asserted a refutation of Einstein's analysis immediately, and his view prevailed. After some decades, it was asserted that feasible experiments could prove the error of the EPR paper. These experiments tested the Bell inequalities published in 1964 in a purely theoretical paper. The above-mentioned EPR philosophical starting assumptions were considered to be falsified by empirical fact. Thus thought experiments belong to a theoretical discipline, usually to theoretical physics, but often to theoretical philosophy. In any case, it must be distinguished from a real experiment, which belongs naturally to the experimental discipline and has the final decision on true or not true, at least in physics. Causal reasoning. The first characteristic pattern that thought experiments display is their orientation in time. They are either antifactual speculations, those experiments which speculate about what might have happened prior to a specific, designated event, or postfactual speculations, those experiments which speculate about what may happen subsequent to a specific, designated event. The second characteristic pattern is their movement in time in relation to the present moment standpoint of the individual performing the experiment, namely, in terms of their temporal direction. Are they past-oriented or future-oriented? Their temporal sense. In the case of past-oriented thought experiments, are they examining the consequences of temporal movement from the present to the past, or from the past to the present? Or, in the case of future-oriented thought experiments, are they examining the consequences of temporal movement from the present to the future, or from the future to the present? 7 types. Generally speaking, there are 7 types of thought experiments in which one reasons from causes to effects, or effects to causes. Prefactual thought experiments. The term prefactual was coined by Lawrence J. Sanner in 1998. Speculate on possible future outcomes, given the present, and ask, what will be the outcome if event E occurs? Counterfactual thought experiments. The term counterfactual was coined by Nelson Goodman in 1947, extending Roderick Chisholm's notion of a contrary to fact conditional. Speculate on the possible outcomes of a different past, and ask, what might have happened if A had happened instead of B. The study of counterfactual speculation has increasingly engaged the interest of scholars in a wide range of domains such as philosophy, psychology, cognitive psychology, history, political science, economics, social psychology, law, organizational theory, marketing, and epidemiology. Semi-factual thought experiments. The term semi-factual was coined by Nelson Goodman in 1947. Speculate on the extent to which things might have remained the same, despite there being a different past, and asks the question, even though X happened instead of E, would Y have still occurred? Semi-factual speculations are an important part of clinical medicine. Prediction. The activity of prediction attempts to project the circumstances of the present into the future. According to David Sarevitz and Roger Pielke, scientific prediction takes 2 forms: the elucidation of invariant, and therefore predictive, principles of nature, and, using suites of observational data and sophisticated numerical models in an effort to foretell the behavior or evolution of complex phenomena. Although they perform different social and scientific functions, the only difference between the qualitatively identical activities of predicting Forecasting and nowcasting is the distance of the speculated future from the present moment occupied by the user, whilst the activity of nowcasting, defined as a detailed description of the current weather along with forecasts obtained by extrapolation up to 2 hours ahead, is essentially concerned with describing the current state of affairs. It is common practice to extend the term to cover very short-range forecasting up to 12 hours ahead. Hind casting. The activity of hind casting involves running a forecast model after an event has happened in order to test whether the model's simulation is valid. In 2003, Dhatfield and his colleagues trained a computer using the data of the surface temperature of the oceans from the last 20 years. Then, using data that had been collected on the surface temperature of the oceans for the period 1857 to 2003, they went through a hind casting exercise and discovered that their simulation not only accurately predicted every El Niño event for the last 148 years, it also identified the looming foreshadow of every single one of those El Niño events. Retrodiction. The activity of retrodiction involves moving backwards in time, step by step, in as many stages as are considered necessary, from the present into the speculated past, in order to establish the ultimate cause of a specific event. Given that retrodiction is a process in which past observations, events and data are used as evidence to infer the process that produced them, and that diagnosis involves going from visible effects such as symptoms, signs and the like to their prior causes, the essential balance between prediction and retrodiction could be characterized as retrodiction, diagnosis, prediction, prognosis. Regardless of whether the prognosis is of the course of the disease in the absence of treatment, or of the application of a specific treatment regimen to a specific disorder in a particular patient. Backcasting. The activity of backcasting. The term backcasting was coined by Don Robinson in 1982, involves establishing the description of a very definite and very specific future situation. It then involves an imaginary moving backwards in time, step by step, in as many stages as are considered necessary, from the future to the present, in order to reveal the mechanism through which that particular specified future could be attained from the present. Backcasting is not concerned with predicting the future. The major distinguishing characteristic of backcasting analyses is the concern, not with likely energy futures, but with how desirable futures can be attained. It is thus explicitly normative, involving working backwards from a particular future endpoint to the present to determine what policy measures would be required to reach that future. According to Janssen, 1994, 503, within the framework of technological development, forecasting concerns the extrapolation of developments towards the future and the exploration of achievements which can be realized through technology in the long term. Conversely, the reasoning behind backcasting is on the basis of an interconnecting picture of demands which technology has to meet in the future, sustainability criteria, to direct and determine the process that technology development must take and possibly also the pace at which this development process must be put into effect. Backcasting is both an important aid in determining the direction technology development must take and in specifying the targets to be set for this purpose. As such, backcasting is an ideal search toward determining the nature and scope of the technological challenge which is posed by sustainable development, and it can thus serve to direct the search process toward new, sustainable technology.